This is task 3, and here we're going to do linear and quadratic approximations. So we are given a function 4 plus sine 2x, and we have to find the linear Lx and the quadratic Qx approximation to the function near x is equal to 1. And after that, what we'll do is we'll approximate the values of f of x for different values of x using the function that we found out, Lx and Qx, and also find out the actual values of these x values using f of x. And then we'll compare or try to notice a pattern or try to see what is actually happening there. So let's get started. Our function here is 4 plus sine 2x. Now, because we are working with both linear approximation and quadratic approximation, we will need to find out here the first derivative and the second derivative of this function here. So the first derivative of the function is 2 cos 2x, and the second derivative of the function is minus 4 sine 2x. Now, to find out the linear approximation, our formula is f of a plus f dash a times x minus a, and for us here we have to find, according to the question, if we look at it again, we have to find out the Lx and the Qx near x is equal to 1. So x is equal to 1 is our a. So this value here is our a. So we'll replace f of a with f of 1 plus f dash of 1 x minus 1. Okay, so now putting our function instead of f of 1 here, we'll have 4 plus sine 2 times 1, because here we have the x here, we'll replace it with the 1. So 2 times 1 is 2. And then we have the first derivative of the function, which is 2 cosine 2x. And instead of the x, if we put the value 1 there, we'll get 2. So again, we have here, I'll put that in a bracket, maybe a square bracket. So we have here 2 cosine 2 times 1, which is 2, times we have x minus 1. Now I'm not going to open this more and keep it here as it is so that it's simple when we work it out. And now let's work on Qx, the formula for which is f of a plus f dash a times x minus a plus 1 over 2 f double dash a times x minus a squared. So now, replacing the a, we'll have to replace it with all 1s, so I'm not going to write that step. I'm directly going for f of 1. That would be replacing the function here, f of x, with 1. So we have here 4 plus sine 2 times 1 is 2, plus we have f dash a, which is f of 1 times x minus 1, which is exactly what we have here. So I'm going to copy it down. That's 2 cosine 2 times x minus 1, and I'm closing the bracket. So we open the bracket next. We have here again, we have here 1/2 times f second derivative of a. So we put here in f second derivative of x the value 1. So we'll get here minus 4 times sine 2 times 1 is 2 again, and we have here x minus 1 squared. Closing the bracket. Here we can cancel, so 2 1s are 2 2s are is 4. So rewriting this whole, we would get here 4 plus sine 2 plus, keeping the bracket as it is here, we have 2 cosine 2 times x minus 1, and here the sign, subtraction sign, will multiply with the plus sign here, which will make it subtraction. And then we have here in bracket 2 sine 2 times x minus 1 squared. So in that case, now we have the formula for Lx here and the formula for Qx here. And we'll need to use this to approximate different values of x, as the question says here. So approximate the values of f of x for x is equal to 0 0.5, 0 0.75, 1, 1.25, and 1.5 using the functions Lx and Qx that we just got. So we'll use these functions here. Let me copy Lx here. So for different values of x, so here first x we have is 0 0.5. Again, this was for part 1 and this is for part 2. So for x equal to 0 0.5 now, we have Lx is equal to the formula here. So what we do is we just replace the x here with 0 0.5, right? So we just replace the x here with 0 0.5, and that will give us the value here as 5.3254444263. Now we have to work with Qx here now. So I'll again copy the Qx formula, which is for the second, or you can say the quadratic approximation. So for Qx, we have here the formula, and we'll be replacing our x values again. So here we have an x and here we have an x. We'll be replacing that with 0 0.5 here, 0 0.5 here, and that will give us the value as 4.87079555. Remember to keep your calculator in gradients during these calculations here. And now what we'll do is we'll also find out what do we get the value for f of x. So our f of x, the formula is 4 plus sine x here. Sorry, 4 plus sine 2x. So 4 plus sine 2x. And for x, we'll replace it with 0 0.5. So times 0 0.5. And that will give us the value here as, let me write it with red because that's what we have been doing before for all the other values. So here we have 4.84170,985. So what do we notice here now? We notice that the quadratic approximation is more closer to the actual value than with the linear approximation, right? Let's go ahead and do for x is equal to 0 0.25 now, or 0 0.75, and see what's the difference. So maybe I'll just copy all of this here, so it's easier for us to replace values and rewrite. Okay, so that's for x is equal to 0 0.5, and now we'll work out with x is equal to 0 0.7, or maybe let's use a different color so it's easy to distinguish. So here we'll have 0 0.25 now. No, sorry, not 0 0.25, 0 0.75. And then I'll replace all the other values. So here we'll replace it with 0 0.75, and so we'll get a different number here. And again, we'll replace this with 0 0.75 and so on. So that will give us different values here, and this too, 0 0.75. So now here we'll have 0 0.75, and that will give us the value as 5.117370,845. And here again, if we replace the values here of x with 0 0.75 and here with 0 0.75, we get here the value as, for quadratic approximation, we'll get here 5.00370 and 8667 here, and then here we put 0 0.75, we get here 4.997494987. So again, if we look at this now, we'll see that the quadratic approximation is more closer to the actual value than the linear approximation here. So let's go ahead and calculate for the rest of the x values. So here we'll have okay. So our x value now will be 1. So of course that will give us different values here. Okay, all right. So here we'll have x is equal to 1. So here we have 1 minus 1, and that gives us the value here as 4.909297,427. And here we have again 1 minus 1 and 1 minus 1 squared. Since these are 1 minus 1 is 0 and 1 minus 1 is 0 here, so these both the values get cancelled actually, and we have the same number again here, which is 4.9099297,427. And for the actual value, we have again, okay, I did not replace this one here, so this should be replaced by 1. And that gives us the same value again, which is 4.9099297,427. So here you don't see a variation because it's getting cancelled at 1. The other approximation values here. So yeah, in this case the value remains same. Now let us work out for other values of x according to the question. So we have still to calculate for x is equal to 1.25. So we'll replace this here now, and this one here. Okay. So here we have 1.25 and 1.25 here, and so on. I'll replace them first so I don't forget any. 1.25. Now the values that we get for 1.25 are, here we have 4.701224009, and here we'll have 4.587568183, and here we have 4.598472144. Now here again, as you can see, here we have 4.59847, and here again we have 4.587. So these are very close. These two are very close, which shows again that the quadratic approximation is more close to the actual value than the linear approximation, which is further. So it seems like by now to us that because every time the quadratic approximation is more closer to the actual value, which shows that the function actually must be quadratic. Let's go ahead and solve for the last part, which was for x is equal to 1.5. So here we have for x is equal to 1.5. So I'll just replace the zeros with 1. That would be enough, and yeah, these values will be different. Okay, so here we have 1.5, and here 1.5, and here also 1.5, and here 1.5. So this gives us the value here as 4.49315 0.059, and here we have the value 4.038501877, and here we have 4.141120008. So again, we can see that this is almost, the linear approximation is almost 4.5, whereas the quadratic approximation is 4.038, which is closer to 4.14 than the linear approximation. So all of this here is showing us that the quadratic approximation is more closer to the actual value than the linear approximation, which means, as you can see, I'll show it to you now. Yep. So it means that as you can see over here, the function is actually quadratic. Therefore, it shows that the quadratic approximation is more closer to the actual value than the linear approximation. So you can see over here the function 4 plus sine 2x here at 0.5, it's, or you can say from 0.5 until 1.5, where we calculate the values here just now, is actually quadratic. And that's why the quadratic approximation was more accurate or more closer to the actual value than the linear approximation in this particular case. And that's the end of task 3.